All right, so we've dealt with changing from polar to rectangular. Now we need to go backwards. We need to be able to do rectangular coordinates to polar coordinates. And then we're going to do some more other stuff after that. So here, we're going to convert these by using two different ones. So if we're talking about polar to coordinate, the polar to, from rectangular to coordinate, to polar, sorry, that means we would need to go ahead and change things from x and y to r theta. So here, to change things from x, y, at least to the r portion of it, we're going to do plus or minus, plus or minus the square root x squared plus y squared. So r equals plus or minus the square root of x squared plus y squared. And this will give us the distance for our r, like how far it's going in with the concentric circles. Now, when it comes to theta, we have two different things that are happening because, we could have some negative x values or positive x values, and so that could throw off what's going on. Now, one of the things also, we said that when we were trying to find angles, when we talked about trig back in the a couple of weeks, probably like 3 or 4 weeks ago, we said that when we're finding an angle, we have to use our inverse. So we said arcsine or inverse for that. So arc or inverse. So this time, instead of us using arcsine, arc cosine, all that good stuff, we're going to use arctan. And we're going to do y over x. And this is only used when x is greater than 0. So when x is positive, that's when we use this first one. When x is negative, we still use arctan. But we do plus pi. So that way it should move it over to a positive answer there for that, hopefully. So when x is a negative number, we use this formula. So when x is greater than 0, when it's positive, we use this first one. When x is less than 0 or is negative, we use the second one. Okay, so now we're going to go to an example where we're going to use that. And then we'll be good with that, and we'll move on to the next part. So here comes example 2.